2022 physics paper 2, it was again well designed paper in terms of managing time very prudently. So if you are a student of either class 12 or 11th going to appear for JEE Advanced shortly, or those of you who have already finished the 2022 JEE Advanced, you can get to know a full detailed analysis of the paper over here. So I'm going to be not solving the question as such, but I'm just going to take you back through the experience of test taking, how you should have picked questions in this particular paper, and how within that 1 hour what would be like a decently good score, what would be a very good score, and what is going to be an excellent score in the paper, how much time each question should have possibly taken for attempting in the test scenario. So question by question, we are going to decode that and we are going to analyze this particular paper. Now, coming to the areas that were tested, a few areas which were not there in paper 1, they have been included in paper 2. So in paper 2, the areas like surface tension has been included. Questions based on ideas of a simple harmonic motion have been included. But there are certain chapters which completely miss out in both the papers. That is, they have never touched upon certain areas. So wave motion, waves related question, other than YDSC, there is a particular question which is there in paper 2. But pure wave motion based question is completely missing in both the papers. Question from AC is missing from both the papers. Question based on Bohr's theory and structure of atom is completely missing in both the papers. But in paper 2, they have included photoelectric effect, which was not there in paper 1. So overall, they have tested majority of concepts. Paper 1, paper 2, both the chapters which have been missed out, I've already informed. So I just mentioned it. Alternating current is completely missing. Wave motion is completely missing. No question is there. So these are two areas where there is no question at all. So now let's directly get into the paper analysis. Let's see question by question. I'm going to tell you here how much time this particular question could have taken in the actual testing scenario, and whether it would have been a wise choice to attempt it or not, whether the question is conceptually tough in terms of calculation, whether it is tough, whether it is time consuming, or it is going to be little easy on the time aspect of it. So that is going to be the major discussion over here, and eventually I'm going to tell you what is going to be a decently good score in the paper, what is going to be a very good score, and what is going to be an excellent score in the particular paper. See, excellent scores, there are few students for whom the flow on the day of exam, they will get into one kind of a flow and they will be able to ace through the paper. So the there might be around maybe say some 10-15 students throughout the country who could have done exceptionally well in this particular paper, but let us leave them aside. They are going to be like kind of outliers. On the day of the exam, so many things fell in place for them and they were able to do exceptionally well. And let's try to understand what would be a decently good score for an aspirant who has prepared well for over a period of 2 years. Whoever has done that preparation, 2 or maybe more. When you start early, maybe it is more than 2 years. So let's get into the question by question analysis. I'll share the screen and let's get started right away. Right, so you see the very first question itself, IITs have started with a bang. It's a conceptually tough question. It's based on kinematics plus simple harmonic motion. Or if the idea of rotation clicks to you, you can maybe use the idea of rotation to solve this particular question. But this rotation idea would click only if you had actually solved this kind of a question prior to facing the examination. On the spot, getting the idea of rotation and solving this is going to be quite a challenge. So even if you don't get the idea of rotation, still kinematics plus SHM could be used to solve the question. But nevertheless, IITs have started off with a bang. So either during the test scenario, you spend some 2 to 3 minutes, you don't get the idea, you move on. So you should not be like sitting and thinking for some 5 minutes and then you still don't get an idea, and you start doing something. It is not that you won't have an idea absolutely and all. You start doing something, but then eventually you don't end up getting the required expression. Well, then you should actually move on in around 2 to 3 minutes. You should not spend more than this. You can leave this question out, and eventually you will see how the scores will fall into place if you do a good time management. Or you spend somewhere around 4 to 5 minutes and you could solve the question. If you got the idea correctly, yeah, maybe then this question takes quite a lot of time to still solve it. So conceptually it is a tough question. Calculation wise there is nothing much, but concept wise, yeah, it's a very good one that IITs have started off with a bang right away. Second one is a pretty concept wise easy, calculation wise easy question. Should have definitely been done in the paper. So in 2 minutes time this should have been done. It's a standard nuclear physics question. Then current electricity, instead of a meter bridge wire being uniform, here they have given a frustrum kind of uniform, sorry, not uniform, a frustrum kind of linearly increasing radius wire they have given. Concept wise it is easy, calculation wise also easy. It's pretty much a standard question where you need to know how to calculate resistance of a frustrum shaped wire. So majority of them who prepare for advanced, they do come across this kind of question. So they should have been able to do it in around 3 minutes to maximum 4 minutes of time. So a doable question. Next, fourth one. So this is a question based on dimensions. So either you start, you see there will be 4 variables, alpha, beta, gamma, delta, and you have to find all these 4 values and you need to add. So concept wise easy, calculation wise it's pretty tough. So either you start off and then you decide that okay, in 1 to 2 minutes you know that 4 equations are going to come, it is going to take some time to solve. Either you move on, or if you had spent some time means you spend some 4 minutes time to get it right. Concept wise it's pretty straightforward. Only you need to convert everything to MLT form, MLT, and of course current also would be involved. So you convert everything to base dimensions and then you set up the linear equations and solve them. Right? Concept wise pretty much an easy question. Then the next one is based on, again, this is a ray optics based question where multi layers are involved. Concept wise it is moderate because you need to read, understand the scenario, and then get the course of action, how to proceed. Calculation wise there is nothing very tough in this. It's a moderate calculation based question, so it is going to take some time, right? So maybe some people decided to do it, some people decided to move on, and eventually we'll see what will be a good score in this particular paper. Sixth one is a very easy question, concept wise very easy, calculation wise very easy. In 2 minutes max this should have been done and tested. It's a question based on Gauss law. Let's move on over here. That's pretty much an easy one. The next one, seventh one, is SHM based question. Just that a spring is given, depending on the length of the spring, accordingly its spring constant is either K1 or K2. So you need to read, understand what they are trying to mention. Concept wise it is pretty much a simple harmonic. One half of the oscillation is going to happen with one particular spring constant, another half will happen with another spring constant. It's a standard question, but it is framed in such a way that you need to understand the meaning of this particular statement and then infer that it is going to be one half with one spring constant, another half oscillation with another spring constant. So calculation wise it is pretty much easy. So you got the idea, you read the question, you got the idea in around 3 to 4 minutes of time, you should have been able to get that right. Then the next one, concept wise it's pretty much an easy one. Calculation wise it does take some time, not very tough, but yeah, it does take some time for you to do the calculation. Concept wise is pretty much easy question only, where you have mirrors, the standard question, relative motion happening, use mirror formula, differentiate, use the ideas of velocity with respect to the pole and solve the question. It's a pretty much a standard question, nothing out of the ordinary that they have tested. So should have been able to do it in around 3 minutes of time. So that's about the numerical part. Now let's move on to MCQs. This is the area where things get pretty nasty in the paper. Either you can fall for the traps or you could intelligently move on. So this MCQs is the area where it is going to make or break the overall performance in this particular paper. MCQs, some people, if they spend too much time and get psyched up, then overall the performance might be little low. But still, even if you are going to get stuck in certain traps, you could manage to still get a decent performance. You will see at the end what is going to be my prediction about the overall scores in this particular paper, what would be a decently good score, and all you will eventually find out. And that's going to come at the end of this particular discussion. So this question over here, this ninth question, concept wise, it's an easy question. It's based on, again, Gauss law and electrostatics. Calculation wise, I'm saying it is moderate because it is going to take time. Each and every option you need to check. It's not like once you do it, you will be able to, for one option you got it, and then based on that you eliminated other options. Not possible. You need to work with each and every option. So definitely it's a time consuming question. So that's why I've taken the time part of it as 5 minutes. You spend time, slowly do it, you get the marks. You should not get psyched up. The very first question of MCQ, again a time consuming one, and so maybe some of you decided that okay, you solved one option, and then you decided okay, like this 3 questions you need to solve, and then one of it you attempted, and then you went to you decided that it's going to be time consuming and you moved on. And that's also fine. But if you spend some time around 5 minutes and you get it right, so these are not the questions which should be the first priority. So there are questions where concept wise easy, there will be calculation wise also easy, time consumption will not be very huge. There are questions like that which amount to a total of around 25 marks in the paper. So those are the questions which should have actually been targeted first. I'm saying for those who have the intention to clear or get some decent rank, clear in the sense somewhere around 2000 to 3000 ranks, you could particularly get by picking the right kind of questions in the particular paper. So let's move on to the next one, 10th one. Again, concept wise, it's a very, very easy question, a current electricity based one where series parallel combination of resistors are involved. But it is just that you need to read the questions. Situation wise, you need to understand what they are saying, and then you have to work with it. Sometimes your brain can get, it can go into a kind of a particular hangover state where you are trying to read, infer, interpret what they are trying to tell. Each and every option, P1 greater than P2, P1 less than P2, Q1 greater than P1, Q2 less than Q1, like this 4 different options are there. So that's where you could actually get psyched up. Concept wise, it's pretty much an easy question. Calculation wise, also moderate, but definitely it is a time consuming one. Could have been done, not that it is very tough to do it and all, but without getting psyched up, you need to spend time to solve this particular question. Conceptually, it's a pretty straightforward one. Right, next. So this is a question you could have decided based on whether you are comfortable with surface tension or not. Heat and thermodynamics clubbed with surface tension. Standard idea of surface tension where expansion of a bubble is happening. The standard considering the advanced kind of preparation that students are expected to do. Concept wise easy, calculation wise also it's moderate. In around 4 to 5 minutes time you should have done this particular question if you decided to attempt. You should decide to attempt or move on based on your practice. If you have previously practiced questions pertaining to expansion of bubbles, then definitely you can spend the time to solve it and get it right. If you have had practice maybe in 2 to 3 minutes also, you can go about checking for the options A, B, C, and D, and you can predict which is correct, which is incorrect. And it all depends on how well you have practiced pertaining to that particular topic. Now, this 12th one, electrostatics question, this is where things actually get too much nasty. If you fall for the trap in this particular question, probably it could end up taking away a lot of your time. Question number 12, very, very tough in terms of calculation. Concept wise also not a pretty straightforward one. Conceptually also you need to think what is the concept that needs to be applied. And there are 2 different scenarios for beta equal to 1/4. There itself you have to see whether it is going to return back or it is just going to reach the origin. And there is one more case where beta is greater than 1, so definitely extremely kind of time consuming. Either you start off with one option say first option you decided 2 to 3 minutes, you whether the first option is correct or wrong, you decide on that, and then you will get the idea that this is going to be time consuming, either you moved on. Or if you are someone where the other questions and all you had spent very less time and got the other questions right, then maybe you spend around 5 minutes or maybe more than that to check for all the 4 options, and then you get the 4 marks. Conceptually it is not a very tough one. It's about using work energy theorem correctly. Okay, then YDSC. So YDSC, a modified one where one part of the slit is in a particular medium, another part of the slit is in a different medium. Conceptually, it's a tough question. Calculation wise, nothing much involved, but you need to get the correct idea of approach. Either you decide in 1 minute, you move on, or you spend around 4 minutes of time to get the concept. It is based on optical path. You need to convert the path in different media to optical path in vacuum, and then you need to decide on this particular question. So previously also IITs have decided tested this kind of a question in the context of a prism and light ray, two different light rays entering a prism and coming out of the prism after two refractions. Based on that, they have tested in the past. So a similar kind of idea, but then they have clubbed this with YDSC this time. And it's a tough one to do it within the exam situation. 14th one, definitely an easy one. Concept wise easy, calculation wise also easy, because they have given the required values for an adiabatic process and isothermal process. Whatever values are required, they have mentioned in the question itself. So calculation wise also it is easy only. This should have definitely been done from MCQs, and this is the last question of the MCQ, I suppose. So you should have spent around 2 to 3 minutes and should have got all the correct options from this. It's about maintaining the temperament, how well you are able to manage your mind without getting psyched up. Now 15th one, a standard rotation question where rolling is happening without slipping, one object rolling on top of another object. Concept wise easy, calculation wise also easy. In 2 minutes this should have been done. Then a photoelectric effect based question, concept wise easy, calculation wise easy, should have been done in 3 minutes. Write 2 equations and solve 2 equations. So these are all easier questions of the paper. You see they're coming towards the end, right? So this is where things get little tricky, how you manage the time in the paper. Then 17th one, errors and measurement based question, a screw gauge based one where a standard question, nothing very tricky in this, just that now the instrument has a zero error. So instead of mentioning zero error particularly, you are required to infer that from the table. So time wise, it is going to require you to infer what they are trying to convey. Things are not directly conveyed in this, that there is positive zero error or negative zero error. So based on the data that is given, you are required to interpret that carefully and you need to solve it. So interpretation will take time, but calculation wise, it is definitely a very easy question. I'm saying concept wise moderate because you need to interpret the concept correctly and then you need to approach. Definitely doable in the test scenario itself. Considering the other kind of questions, you could definitely consider this. You could attempt this one instead of doing the other time consuming questions. 18th one is a very easy question, concept wise easy, calculation wise easy. You have to find magnetic field of a straight current carrying wire and circular current carrying wire. Direct question this is. So this is about the paper. Now overall, let me tell you what are the questions numbers I am just showing below. In 1 hour time, what could have been done, you can see a table over here, right? So from numericals, as per my predictions, 2, 3, 6 and 8, these should have been done in the test itself. From MCQ, 10 and 14 should have been done. From single correct type, 15, 16 and 18 should have been done. The other ones, they are little bit time consuming, so you need to decide how they have to be tackled within the testing scenario. So overall, a decent score in the particular paper. These questions, they are easy ones conceptually, calculation wise also they are not very tough. So these should have been tackled within the testing scenario. Whereas the other ones over here, probably depending on the practice, depending upon how much of time availability a student has had, right, these questions also could have been done. Maybe at least partly in this MCQ, part of it partially could have been done. You spend some time on 17th one, you get it right. That is the errors and measurement based question. So overall, in this particular paper, a decent score would be 25 plus. Very good score would be in this range. Somebody got into the flow, right, they got 45, more than 45. That would be an excellent score in this particular paper out of 60. That is. So yeah, this is my take on this particular paper. What could have been the scores that students could have obtained. You just come back after the official scores and ranks are going to come out, and just see whether what I have predicted for what is a decently good score, what is a very good score, what is an excellent score in the paper, whether they are going to match or not. Now this excellent score, which is like 45 plus, see, there will be some people for whom on that day things fell in place nicely, the mind went into a flow. Of course, you need to be a little bit lucky also. The areas from where you had actually practiced quite a lot of questions, from that areas, nice tough questions came, and students were able to tackle it. But that's kind of, you can say, it's a blessing in disguise. So it's God's blessing, which I mean, it's their past efforts which come into play over there. See, you can say maybe I'm expecting around 15, 20 of them throughout the country to get that 45 plus score. A majority of them where ranks are going to be between 100 to 1000 or 1500, they would fall in that category of 30 to 45. 25 plus would be a decent score. Those who are getting like say 2000, 2500, 3000 ranks, their score would be like 25 plus in this particular paper, right? So that's about it over here.